The sun has always been there, watching over us like an ancient guardian. It rises in the east and sets in the west, marking the rhythm of our days, our seasons, and even our lives. It has been burning for billions of years before humans existed, before the dinosaurs, even before the earth itself took its final shape. It is so much more than just a ball of fire in the sky. The sun is the reason we exist, the reason there is life on earth at all. But like everything in the universe, the sun is not eternal. It was born from the same cosmic forces that shape galaxies, and one day it will die. Its end will not be sudden, like a flickering candle going out. Instead, it will be a long, slow, and dramatic transformation, a process that will reshape the entire solar system. Before we begin this journey into the sun's future, let's take a moment to appreciate what it truly is. The sun is not just a light in the sky. It is a massive sphere of nuclear fire, a fusion-powered engine that generates more energy in 1 second than all of humanity has ever used in its entire history. Imagine the largest explosion you can think of. Now multiply that by a billion. That is what happens inside the sun every single second. At its core, temperatures reach 15 million degrees Celsius, so hot that atoms themselves are torn apart, allowing hydrogen to fuse into helium. This process, called nuclear fusion, is what keeps the sun burning. It releases an enormous amount of energy, which travels outward in the form of light and heat, eventually reaching us on Earth. Without this energy, nothing on our planet would survive. Plants need sunlight to grow. Animals rely on plants for food, and humans in turn depend on both. Even the weather, the ocean currents, and the air we breathe are influenced by the sun's power. It is the master of our world, but even masters have their limits. One day the sun's fuel will begin to run out. The delicate balance that keeps it stable will shift, and the sun will start to change. At first the differences will be small, almost unnoticeable. But as time passes, the transformations will become more extreme. The sun will swell, growing larger and hotter, until it becomes unrecognizable. Before we witness this incredible transformation, we must go back in time, to the very beginning, to the moment the sun was born. Because to understand how something will die, we must first understand how it came to life. Before the sun became the brilliant, life-giving force we know today, it was nothing more than a cloud, a vast, cold, swirling mass of dust and gas drifting silently through the Milky Way. It was just one of countless clouds in space, remnants of ancient stars that had exploded long ago, scattering their elements into the void. These cosmic clouds, known as nebulae, are the birthplaces of stars. For millions of years, this cloud remained undisturbed, floating in the dark depths of space. But then something changed. Perhaps it was the shock wave from a distant supernova, the violent death of another star, that passed through the cloud and triggered a chain reaction. Or perhaps gravity itself, the silent architect of the universe, slowly pulled the gas together over time. Whatever the cause, the cloud began to collapse in on itself. As it shrank, it spun faster, just as a figure skater spins more rapidly when pulling their arms in. The cloud flattened into a disk, and at its center a dense core began to form. This was the earliest stage of what would one day become our sun. At first the core was cold and dark, hidden within thick layers of dust, but as more and more gas was pulled inward, the pressure increased. The atoms inside the core were squeezed together, moving faster and faster, generating heat. Over thousands of years, the temperature climbed, reaching thousands then millions of degrees. Then something extraordinary happened. At around 15 million degrees Celsius, the atoms of hydrogen began to fuse together, forming helium and releasing an enormous burst of energy. This was the moment of ignition, the moment the sun was born. A brilliant new star had appeared in the universe, lighting up the surrounding space with its golden glow. But the sun's birth was not an isolated event. Around it, the leftover gas and dust from the nebula began to form planets, moons, and asteroids. Some of these fragments clumped together to create rocky worlds, while others remained as swirling clouds of gas. Over millions of years, these planets settled into their orbits, circling the newborn sun like dancers around a flame. Earth was one of these planets. At first it was a barren, hostile world, covered in molten rock and bombarded by asteroids. But as the sun continued to shine, its warmth began to shape our planet, turning it from a lifeless rock into a world capable of sustaining life. The sun became our protector, our source of energy, our constant companion in the sky, and so, for the last 4.6 billion years, it has burned steadily, casting its golden light upon Earth. Day after day, century after century, it has remained unchanged, a silent witness to the rise and fall of civilizations. But even the mightiest of stars have a limit. As we move forward in time, we will witness the first signs of the sun's inevitable decline, the subtle shifts that will mark the beginning of the end. For billions of years, the sun has burned with an almost unwavering steadiness. It rises each morning, sets each evening, and from our perspective on Earth, it seems as though it will shine forever. But deep within its core, an irreversible process is unfolding. The sun is aging. To understand how, we need to look inside. At its heart, the sun is a nuclear furnace, fusing hydrogen atoms into helium through a process known as nuclear fusion. This
T-minus
fusion
5,
releases immense
4,
amounts of energy,
3,
which pushes
2,
outward,
1.
counteracting the force of gravity
Booster
that
ignition
constantly tries
and
to
liftoff
crush the
of
sun
Discovery,
within itself.
hoisting
This
harmony
delicate
to the
balance is
heavens
what keeps
and
the
opening
sun
new
stable
gateways for
and allows it
international
to shine
science.
so brightly.
Discovery has cleared the
But there's a
tower.
problem. Hydrogen, the sun's primary fuel, is being consumed. Every second, the sun fuses 600 million tons of hydrogen into helium. This might sound like an endless supply, but in the grand scheme of things, it's not. Hydrogen is finite, and as the sun burns through its fuel, subtle but inevitable changes take place. Over time, the helium byproduct accumulates in the sun's core, while the amount of usable hydrogen shrinks. This means that the sun must burn its remaining hydrogen at a faster rate to maintain the same level of energy output. The result? A sun that is gradually getting hotter and brighter. Right now the sun is about 30% brighter than it was when Earth first formed. And in another billion years, it will be so hot that Earth's oceans will begin to evaporate. The planet that once teemed with life will become a dry, inhospitable wasteland. But this is just the beginning. Over the next several billion years, the changes will accelerate. The sun will continue to expand, growing larger and hotter, until it reaches a tipping point, a moment when the balance that has held it together for so long will begin to unravel. The sun we know today is calm and stable. It provides warmth without being too hot, light without being too dim. But that will not always be the case. Slowly but surely, it is marching toward its ultimate transformation, a future where it will no longer be the familiar, gentle star that has nurtured life on Earth. The sun's fate is sealed, written in the very laws of physics. The only question that remains is when the final stages of its life will begin. And when that time comes, the sun will not simply fade away, it will explode into something unrecognizable. Imagine standing on Earth and looking up at the sky, expecting to see the familiar golden sun that has warmed our planet for billions of years. But instead the sky is dominated by something terrifying and alien, a massive glowing red giant that has swollen to hundreds of times its original size. It no longer sits neatly in the sky, like a small comforting orb. Instead it stretches across the heavens, like an enormous burning wound, bathing everything in an eerie crimson glow. The world beneath it is unrecognizable, reshaped by the sun's growing power. The transformation began slowly, over millions of years, but by the time the sun reached this stage, the changes became undeniable. Its outer layers expanded outward, devouring everything in their path. Mercury, the smallest and closest planet to the Sun, was the first to fall. The once rocky, cratered world had already been scorched by intense heat for billions of years, but now it stood no chance. As the Sun's atmosphere grew, Mercury was pulled into the inferno, vanishing into the depths of its parent star. No trace of it remained. It was as if it had never existed at all. Venus was next. The planet, known for its thick clouds of sulfuric acid and extreme greenhouse effect, was already one of the hottest places in the solar system. But nothing could prepare it for the Sun's wrath. As the expanding star crept closer, Venus's thick atmosphere began to boil away. The swirling toxic clouds that had once hidden the planet's surface were stripped away, revealing a scorched wasteland beneath. Then, like Mercury, Venus was pulled into the Sun's growing mass, disappearing forever. Earth was still standing, but only just. The planet we once called home had become something completely different. The once vast oceans had turned into steaming cauldrons, sending billowing clouds of vapor high into the sky. The atmosphere itself was being stripped away, unable to withstand the Sun's unrelenting heat. The ground cracked and split apart, as the temperatures climbed higher than anything recorded in history. Mountains, which had stood tall for millions of years, crumbled into dust. Rivers evaporated. Forests were reduced to ash.
T-minus 5, 4, 3, 2, 1.
Even Mars,
Booster ignition.
once a cold and barren desert, briefly experienced a strange transformation. As the Sun grew, the planet received more warmth than it had in billions of years. Ice caps melted, releasing long-trapped water onto the surface. For a fleeting moment, it seemed as though Mars could host life. But it was all an illusion. The Sun's expansion was not a gift. It was a curse. Soon Mars, too, would be stripped of its atmosphere, turned into yet another lifeless rock in space. Further out, the gas giants, Jupiter, Saturn, Uranus, and Neptune, remained distant from the chaos, but they were not safe. The immense gravitational shifts caused by the Sun's changes began to disrupt their orbits. Moons that had long been stable started to drift. Some were pulled closer to their parent planets, crashing into them in spectacular collisions. Others were flung out into the void, lost forever in the dark expanse of space. But despite its immense size, the Sun was not infinite. This phase of its life was temporary. Deep inside its core, something even more dramatic was happening, something that would determine the Sun's ultimate fate. The red giant phase was just another step toward an even greater transformation, one that would leave behind a ghost of the star that once was. As the Sun continues to expand, its outer layers grow thinner, stretching out into the vast emptiness of space. It is no longer the brilliant, golden star that once ruled the solar system. Instead, it has become a massive swollen giant, a dim reddish beacon looming over what remains of the inner planets. The Sun is dying, but even in its death, it still holds immense power. For millions of years, this bloated version of our once familiar Sun burns with an eerie flickering light. It no longer shines with the steady brilliance we once knew. Instead, its glow pulses unevenly, like the labored breath of an ancient, exhausted giant. Every so often, massive eruptions ripple across its surface, sending enormous waves of solar material into space. These powerful outbursts, known as stellar winds, carry vast amounts of gas and dust, forming an expanding shell of glowing plasma around the dying star. At this stage, the Sun is struggling to maintain stability. The delicate balance that once held it together, the perfect interplay between the outward push of fusion and the inward pull of gravity, is beginning to collapse. For billions of years,
The sun's core has been fusing hydrogen into helium, the process that fueled its brilliant light. But now, that hydrogen is all but gone. The core has become a dense, overheated ball of helium, desperately searching for a new fuel source. In response, the sun attempts to fuse heavier elements. Helium begins to fuse into carbon, releasing bursts of energy that momentarily stabilize the star. But this is only a temporary solution. Unlike massive stars that can continue this process with even heavier elements, our sun is not large enough to sustain fusion beyond carbon. This marks the beginning of the true end. With each passing millennium, the sun loses more of itself. The sun loses more of itself. Its outer layers are no longer tightly held together, and they start to drift away. The solar system, once a well-ordered collection of planets, moons its stars, moons its solar system, once a well-ordered collection of planets, moons and myths. The remaining rocky bodies are either scorched beyond recognition or flung into the darkness by gravitational disturbances. The once majestic rings of Saturn, those delicate bands of ice and rock, are seasoned Even as the sun fades, its influence extends beyond what we can see. The heliosphere, the vast bubble of charged particles that once shielded the solar system from cosmic radiation early storms. Without it, the remnants of the solar system are exposed to the full force of the universe's chaotic energy. Cosmic rays once deflected by the sun's magnetic field now bombard the system unopposed. The remaining gas giants, Jupiter, Saturn, Uranic field, now bombard the system unopposed. The remaining gas giants, Jupiter, Saturn, Uranus, and Neptune, are in turmoil. The gravitational shifts caused by the sun's loss of mass disrupt their orbits, sending them drifting away from their original positions, Some of their moons, once locked in stable orbits, spiral into primal infernal crashing over clouds,
Others are ejected entirely, cast out into the void as lonely wanderers with no home. For Earth, if it has somehow managed to survive up to this point, the situation is beyond hopeless. Long before now, it has become an airless, lifeless rock. The sun's heat has stripped away the last remnants of its atmosphere, and its surface is a barren wasteland. Any trace of the civilizations that once thrived here,
T-minus
our
5,
cities,
4,
our monuments,
3,
our histories,
2,
has been erased
1.
by time and fire.
Booster
The continents
ignition
themselves
and
have been
liftoff of
reshaped
Discovery,
by the unrelenting
hoisting
heat.
harmony to the
Their
heavens.
surfaces cracked
and
and molten. And yet, even in this final stage, the sun still has one last act left in its long, incredible life. As it continues to shed its outer layers, a glowing shell of gas forms around it, a breathtaking structure known as a planetary nebula. This nebula expands outward, stretching across the vastness of space, glowing with the ghostly light of the sun's fading core. These nebulae are among the most beautiful sights in the universe, their delicate tendrils of gas illuminated in shades of red, blue, and green. But at the heart of this cosmic masterpiece, something even more extraordinary is taking shape. As the sun's outer layers drift away, its core remains behind, growing denser and hotter. This is the beginning of the sun's final transformation into a white dwarf, the last stage of its long journey. The sun, once the radiant heart of our solar system, has now reached the end of its active life. Its outer layers have been stripped away, forming a vast, glowing cloud of gas, known as a planetary nebula. This luminous shell, stretching across light years of space, is all that remains of the sun's former self. But at its core, something extraordinary is happening. As the outer layers drift into the darkness, the sun's heart, the remnant of its once mighty core, is collapsing under its own gravity. No longer able to sustain nuclear fusion, it has become an ultra-dense sphere of matter, a strange and alien object known as a white dwarf. This is the sun's final form, a small glowing ember of a once powerful star. But what exactly is a white dwarf? Unlike the fiery massive stars that explode in supernovae and become neutron stars or black holes, a white dwarf is a more subtle but equally fascinating endpoint. It is a remnant of pure matter, compressed to an almost unimaginable density. The Sun, which once spanned over 1,000,000 kilometers in diameter, has now shrunk to a fraction of its former size, no larger than Earth itself. And yet, despite its small size, it still contains most of the Sun's original mass. This means that a single teaspoon of white dwarf material would weigh tons far heavier than anything found on Earth. A star that shines without fire, unlike its previous forms, the white dwarf no longer generates energy through fusion. It doesn't burn fuel like the Sun once did. Instead, it glows purely due to residual heat, like a cooling ember left behind after a great fire. Even though fusion has ceased, this remnant is still incredibly hot. At first it burns at temperatures exceeding 100,000 Kelvin, far hotter than the Sun's surface ever was. Over time, however, this intense heat slowly begins to fade. Without a new energy source, the white dwarf is doomed to an eternity of cooling and dimming. But this process is incredibly slow. So slow that even after billions of years, the white dwarf will still be visible, casting a faint glow into the cosmic night. But even as it fades, the white dwarf remains one of the strangest objects in the universe. Unlike ordinary matter, which follows familiar physical rules, the matter inside a white dwarf behaves in a way that defies intuition. This is due to a concept known as degeneracy pressure, a quantum mechanical force that prevents the white dwarf from collapsing further under its own gravity. In normal stars, the outward pressure from nuclear fusion balances the inward pull of gravity, keeping the star stable. But in a white dwarf, fusion is no longer happening. Instead, electrons are packed so tightly together that their quantum properties create a counteracting force. This electron degeneracy pressure is the only thing stopping the white dwarf from collapsing further into an even denser state. The fate of the solar system in the age of the white dwarf. By now, the solar system as we once knew it is completely unrecognizable. The Sun has lost much of its mass, and this has drastically altered the orbits of the remaining planets. Without the Sun's strong gravitational pull, Jupiter, Saturn, Uranus, and Neptune have slowly drifted outward, moving into the vast frozen reaches of interstellar space. The asteroid belt, once a bustling region of rock and ice, has dispersed, its pieces either ejected into deep space or pulled toward the dim glow of the white dwarf. Even Pluto and other distant objects in the Kuiper belt have begun to fade from view, their surfaces long since frozen in the eternal cold. And then there is Earth, or what little remains of it. If Earth was not engulfed during the red giant phase, it has now become a lifeless husk. All signs of its former beauty, its rivers, forests, and oceans have been erased by time. Its surface is scorched and frozen in turns, depending on how far it has drifted from the fading Sun. The planet's atmosphere is long gone, stripped away by solar winds millions of years earlier. If any remnants of human civilization still exist, perhaps deep underground or on distant unrecognizable landscapes, they would be buried under layers of dust and ice. If some ancient alien explorers were to stumble upon Earth in this era, they might find nothing more than a barren, cratered world, with no signs that it was once home to intelligent life. But even if Earth is gone, the Sun's legacy is not yet over. The planetary nebula it left behind will continue to drift outward, eventually fading into the darkness of space. The elements released from the dying Sun, carbon, oxygen, and heavier elements formed in its final days, will mix with the cosmic dust, seeding future generations of stars and planets. The final fate: from white dwarf to black dwarf. For billions of years, the white dwarf will continue to glow faintly, slowly radiating away its last traces of heat. But eventually, after an almost incomprehensible span of time, It will cool to the point where it no longer emits any visible light. At this stage, it will become what scientists call a black dwarf, a cold, dead remnant of a star.
T-minus
drifting
5,
silently
4,
through the cosmos.
3,
However,
2,
this phase is
1.
purely theoretical.
Booster
because the
ignition
universe itself
and
is
liftoff
not
of
yet old
Discovery,
enough for any
hoisting
black dwarfs
harmony to the
exist.
heavens
White
and
dwarfs
opening
take
new
trillions
gateways
of
for
years to
international
cool to this
science.
point,
Discovery has
meaning
cleared
that
the
not
top.
a single black dwarf has yet formed in the observable universe. One day, however, as the universe ages and grows ever colder, the sun's white dwarf remnant will reach absolute darkness, becoming completely invisible against the vast emptiness of space. It will be nothing more than a frozen ball of degenerate matter, one of the last quiet echoes of the solar system's existence. And then at last the story of the sun, the star that gave birth to life, that illuminated Earth for billions of years, will come to its ultimate end. As we move forward into an age far beyond human comprehension, the sun, once a blazing beacon in the sky, the giver of warmth, light, and life, has become something eerily different. No longer a white dwarf, it has now faded into something far colder, far more mysterious. The process that began trillions of years ago has finally reached its conclusion. The sun is no longer visible. It is now a black dwarf, a cosmic ghost, drifting through space in complete silence. But what exactly is a black dwarf? This is a stage that no star in the universe has yet reached, because the time required to form one is longer than the current age of the universe itself. To understand just how vast this time scale is, consider this. The universe from the moment of the Big Bang to today is roughly 13.8 billion years old. But the process of cooling a white dwarf into a black dwarf takes trillions upon trillions of years, hundreds, even thousands of times longer than the entire history of existence, as we know it. This means that if we were to fast forward into the far distant future, an era where galaxies have dimmed, where new stars no longer form, where the night sky is an abyss of fading embers, only then would the sun's transformation be complete. The white dwarf that once glowed faintly has now lost its final traces of heat. It has cooled to the point where it no longer emits any energy. It no longer shines. It has become a black dwarf, a frozen remnant of what was once a mighty star. A star that no longer burns, unlike a black hole, a neutron star, or even a white dwarf. A black dwarf does not radiate heat or light. It is simply a cold, dense, invisible mass. It still has gravity. It still has mass, but it is practically undetectable in the void of space. If we could somehow travel to this distant future and stand near where the sun once burned in the sky, we would see nothing. There would be no sunrise, no golden glow on the horizon. The sun's position would be marked only by a dark, cold sphere drifting silently through space. It is difficult to imagine what this lifeless object might look like up close. Without heat, it would be colder than the deepest voids of space. Its surface, once a seething sea of plasma, would now be a hard, dense crust, possibly composed of crystalline carbon. In fact, some theories suggest that a black dwarf might be a gigantic diamond floating in space, an unimaginably large gem, formed under the intense pressure of a dead star's core. If any surviving remnants of the solar system's planets still existed, perhaps frozen asteroids or shattered moons, they would orbit this cold remnant in eternal silence. Earth, long since reduced to a barren rock, or perhaps even obliterated altogether, would be nothing more than a distant memory. The fate of the solar system in a universe without light. At this point, the universe itself has changed dramatically. The galaxies we know today, spiral giants filled with stars and nebulae, have long since stopped forming new stars. The lights of the cosmos are going out. In this distant future, everything is slowing down. The stars have burned through their fuel. Even the longest-lived red dwarfs, stars that can survive for trillions of years, are beginning to die. One by one, They are fading into darkness. Galaxies that were once glowing with energy are becoming nothing more than collections of dim dying stars, scattered across an expanding void. 2. And then there are the planets, if any still remain. Those that were not flung into interstellar space long ago continue to orbit their black dwarf stars in frozen silence. Without heat, without energy, they are completely lifeless worlds, locked in an eternal night. Their surfaces are colder than anything imaginable, colder even than the most extreme winters Earth ever experienced. There is no wind, no water, no movement, only stillness. Even the giant planets, Jupiter, Saturn, Uranus, and Neptune, have long since changed. Their once beautiful atmospheres have frozen solid. Their swirling storms which raged for millions of years have stopped. If these planets have survived at all, they are now motionless, ice giants, locked in orbits around a star that no longer shines. Saturn no longer shines, the last light of the universe, the end of everything. But even this is not the end. The sun's black dwarf remnant will continue to exist for an almost unfathomable length of time. Longer than the age of the universe, longer than the formation of galaxies, longer than anything we can comprehend. Eventually, however, even black dwarfs themselves may not be eternal. Some theories suggest that, over unimaginably long periods, even these dense objects will begin to break apart. Atoms themselves may decay, collapsing into a mist of fundamental particles. If this happens, then the sun, its final frozen form, will slowly dissolve into the fabric of space. And then, at last, nothing will remain. The sun, the planets, the entire solar system, all of it will be gone.
T-minus 5, 4, 3, 2, 1. Booster ignition and liftoff of Discovery, hoisting Harmony to the heavens.
There is no more motion. The universe has expanded so much that no new structures can form. It is a vast, empty black void stretching out eternally with no end, no purpose, and no possibility of renewal. This is the fate of the sun. This is the fate of everything. And yet, somewhere, deep in this endless darkness, the remnants of the sun may still drift, a cold, dead relic of a universe that once furnished the sun with Mars. Now that our once mighty sun has faded into a black dwarf, the story of our solar system is the black dwarf. But even though the sun no longer shines, even though its warmth is forever gone, even though Earth still exists and stillness is forever gone, stillness is nothing more than a frozen barren world, a still and atomic world. The sun itself is still there. The black dwarf is not the star in the traditional sense. It no longer fuses hydrogen, no longer lights. It no longer gives off heat, but it is still an object in space, using the stars, shifting sunlight through the cosmos. It is still an object in space, splitting time. It remains a ghostly reminder of a time when we were promised. Does this black dwarf remain untouched? Does this black dwarf remain untouched? A universe without purpose, the fate of a black dwarf. The fate of a black dwarf in the far future. And yet, scattered throughout this August, black moons. And yet, scattered throughout this sun, for remnants around the stars, the rainbows stinging stars, the rainbows the spiraling galaxies that erase, unshaped the universe are gone. There is no longer
The last encounters. Could the sun's fate still change, even in the distant future, when nearly all light has disappeared from the universe? Some black dwarfs may still interact with other objects. The sun, now nothing more than a frozen sphere, may one day encounter another drifting remnant in space. Imagine, for a moment, a scenario that seems almost impossible. Given the vastness of the cosmos, somewhere deep in the darkness, the sun's black dwarf remnant drifts quietly. For trillions upon trillions of years, it has wandered the void, untouched, unseen. It has no energy, no heat, only gravity. But then, something appears on the horizon, a faint shadow in the blackness, another dead star, perhaps another black dwarf also drifting alone in the cosmos. Gravity begins to pull them together. Over an almost unimaginable timescale, these two remnants begin to spiral toward one another, drawn together by their remaining gravitational pull. There is no rush. This process happens so slowly that it makes the formation of galaxies look like an instant by comparison. And yet, eventually, these two dead stars will collide. What happens then? Could this collision produce a brief flicker of light in the eternal darkness? Some scientists theorize that when two black dwarfs collide, their combined mass might be enough to trigger one final nuclear reaction, creating a burst of energy in a universe that has been dark for countless eons. This wouldn't be the same as the sun's original light. It wouldn't reignite the solar system or restore warmth to the frozen remains of planets. But for the briefest moment, perhaps just a few seconds, a dying universe might witness one final spark from the remnants of an ancient star. And then, silence once more. The endless expansion. Will the sun be lost forever? Even if the sun never collides with another black dwarf, even if it drifts alone for eternity, there is still one final fate awaiting it: the expansion of the universe itself. Scientists believe that the universe is not just expanding, but that this expansion is accelerating. Over time, everything in the cosmos is being pulled farther and farther
5,
apart.
4,
Galaxies that were
3,
once clustered
2,
together are
1.
now racing away from each other.
Booster ignition
Eventually,
and
even
liftoff of
gravity
Discovery.
itself may no longer be strong enough to hold objects together. If this continues, then the sun, now an invisible frozen husk, may face a fate even more unsettling than eternal drift. It may be torn apart at the most fundamental level. As space expands faster and faster, the very fabric of reality itself may stretch to the point where even atoms can no longer hold together. Matter may begin to dissolve, breaking down into a sea of subatomic particles scattered across an infinite void. If this happens, then the sun, its last remnant, will be no more. Nothing will remain. The heat death, the final fate of the cosmos. This is the ultimate conclusion of not just our sun, not just our solar system, but the entire universe. A state known as the heat death of the universe. In this final era, there is no more energy left. No more stars, no more light, no more galaxies, no more motion. Even black holes, the last remaining giants of the cosmos, have evaporated. Everything that once existed has been reduced to a thin mist of particles, drifting endlessly in absolute darkness. This is not a fiery explosion, nor a sudden cataclysm. The end of the universe is a slow, quiet fading, a process that takes so long that it makes the entire history of humanity seem like a blink of an eye. And with that, the story of the sun, a story that began billions of years ago with a bright burning star giving life to an entire planet, finally reaches its final page. The sun was born, the sun burned, the sun died, and then nothing. So now we reach the darkest chapter in the sun's story. It has faded into a lifeless black dwarf, drifting through a dying universe, where time itself seems to have lost all meaning. The last stars have burned out. The last galaxies have unraveled into nothingness. Even black holes, the ancient cosmic titans, have evaporated into thin radiation. And yet, there's something haunting about the idea that the sun, this once magnificent ball of fire, could simply vanish, reduced to nothing, erased from existence, with no trace that it was ever here. After all, our entire history, every human civilization, every great discovery and tragedy, every life that was ever lived, all of it began under the light of this single star. Could it all just be forgotten? Or is there something left? Something waiting? The memory of light. Could the sun's legacy survive? In a universe of cold, empty darkness, where nothing remains of the past, could there be a way for the sun's memory to live on? Even though the black dwarf itself will eventually dissolve into fundamental particles, some scientists believe that traces of our sun might still persist in a way that seems almost supernatural, through the echoes of radiation left behind. You see, even in death, stars leave behind something called Hawking radiation, the same mysterious energy predicted to slowly evaporate black holes. While individual particles might be tiny, over vast stretches of time, they could continue to ripple outward, stretching endlessly into the void. And though no human, no being, no intelligence of any kind may remain to witness it, these final remnants of the sun's existence might still be drifting through the cosmos billions of years from now. Imagine this: somewhere impossibly far away, in a universe where no light remains, a single weak pulse of energy flickers for a fraction of a second, a remnant of a star that once burned brightly, that once gave warmth to planets and life. No one will ever see it, but it is there. A whisper of a time when the universe was young, a ghost of the sun, lingering at the very edge of existence. Could the universe be reborn? A new beginning? If this was truly the end, then the story of the sun would simply close here. But some scientists wonder, is this really the final fate of everything? Or could there be one last, almost unimaginable twist? For years, astrophysicists have debated what happens after the heat death of the universe. Does the cosmos remain frozen forever? Does it expand endlessly into pure nothingness? Or could something new be waiting on the other side? Some radical theories suggest that, while our universe as we know it may end, it might not be the end of the entire story. Instead, there could be a way for the universe to be reborn, a process where time itself resets, a new cycle begins, and an entirely new cosmos is created from the ashes of the old. In this scenario, everything, every star, every galaxy, every remnant of the past, could be compressed into an infinitely small point, just like at the beginning of the Big Bang. And then, boom, a new explosion, a new universe, a new sun. Could this happen? No one knows for sure, but it raises a strange and beautiful possibility, that even after the sun dies, even after everything fades into darkness, there might one day be another sunrise, a new dawn. Perhaps in another time, in another place, under the light of a new star, another world will be born, another civilization will rise. And maybe, just maybe, they will look up at their sky, wondering where they came from, just as we once did. The sun may die, but perhaps in some way, its story will never truly end. The universe is a place of cycles. Stars are born, they burn brightly, they die, and from their scattered remains, new stars take their place. Galaxies collide and merge, black holes devour matter and fade away, and even time itself might one day restart. But what about the sun? When its final chapter is written, when the last atoms of its existence dissolve
T-minus
into
5,
abyss,
4,
does anything
3,
remain
2,
for billions of
1.
years? Our sun has
Booster
shaped the
ignition
very
and
fabric of the
liftoff of
solar
Discovery,
system. It
hoisting
dictated the
harmony to
movements
the
of
heavens
planets,
and opening.
controlled the tides, and fueled the evolution of life. Stunned. But what if, in some way, the sun's influence continues? even after its physical form has vanished. There's a concept in physics called gravitational memory. It suggests that whenever a massive object like a star or black hole exerts gravitational force, it leaves an imprint on the surrounding fabric of space. Even when the object disappears, that imprint, a distortion in the structure of reality itself, could still linger, like the ghost of something that once was. Could this mean that long after the sun is gone, space itself will still carry an invisible trace of where it once burned? Could the planets, even in their frozen, lifeless state, continue to orbit the memory of their lost star, locked in an eternal dance with something that no longer exists? The phantom sun. An echo in the darkness. This idea brings us to a strange and eerie possibility, that long after the sun has faded from existence, something of it might still be detectable, not as light, not as heat, but as a whisper in the very structure of space-time. Imagine an ancient, distant civilization, perhaps billions of years in the future, or perhaps from another universe entirely, studying the remnants of long-dead stars. As they scan the cosmos, they notice something peculiar, an invisible presence, a region of space where time itself seems slightly altered, distorted by something long forgotten. They wouldn't see a star, they wouldn't detect its heat, and yet somehow they would know that something was once here, a star that burned brightly, that gave life, that shined over a world teeming with existence. They might not know its name, they wouldn't know about Earth, or the civilizations that once gazed up at its golden glow. But in some way, across the endless stretches of time, the sun would not be completely lost. The final light, a last glimmer in the universe, even after everything else fades, there's one more place where the sun might endure, in the cosmic background radiation, the last light of the universe. The cosmic background radiation is a faint, ghostly glow that fills the universe, a remnant from the birth of the cosmos itself. It is the ultimate record of everything that has ever happened, stretching all the way back to the Big Bang. Scientists believe that, even as the universe continues to age, this radiation will persist. It will fade, growing weaker, cooling, stretching further into the invisible depths of space, but it will never disappear entirely. And that means that somewhere within this final glow, there may be a piece of our sun, not in the form of physical matter, not as an object we can touch or see, but as part of the great story of the cosmos, embedded forever in the echoes of creation. A small, quiet ripple in the fabric of everything. Even after the sun is gone, even after its last traces have dissolved into the void, its light will still be traveling. It will continue to move through space, endlessly, forever. And maybe, just maybe, someone somewhere in some distant time will see it. As we travel deeper into the future, beyond the sun's final days, a fascinating question emerges. What legacy does a star leave behind? When a massive object like the sun has influenced an entire solar system for billions of years, does its story truly end when its light goes out? Or does its impact ripple forward, touching worlds and phenomena we cannot even begin to imagine? The sun has not only been the source of life and warmth for Earth, it has been the architect of everything we know. Its gravitational pull arranged the planets into their stable orbits. Its solar wind carved away atmospheres, shaped magnetospheres, and even dictated the fate of distant celestial bodies at the edges of the solar system. But once the sun is gone, its legacy will not vanish. The eternal influence of gravity. Long after the sun fades into a white dwarf and then a cold, dark remnant, its gravitational pull will continue to echo through the cosmos. Gravity is not something that disappears. It is the most fundamental force that ties everything together. Even when the sun becomes a mere husk of its former self, it will still be pulling on the remains of its planets. The dead Earth, drifting in frozen silence, will continue to orbit this tiny relic of a once mighty star. But over time, The balance of the solar system will shift. Without the sun's nuclear fusion producing outward pressure, its mass will shrink. The loss of mass means that its gravitational hold will weaken. Planets will slowly drift outward, their orbits growing larger and more unstable. Some celestial bodies, like asteroids, moons, or even rogue planets that once lurked in the distant Oort cloud, could be flung into space, escaping the system entirely. Others might spiral inward toward the white dwarf, colliding in a final cosmic dance of destruction. Could it be that long after the sun has died, a wandering planet, perhaps one that once belonged to our solar system, might drift into an entirely new star system, bringing with it the silent memory of the world it once knew? Cosmic recycling. The sun's elements will seed new worlds. The sun, like all stars, is a cosmic alchemist. Over billions of years,
T-minus 5, 4, 3, 2, 1.
though the sun's core
Booster ignition and liftoff of Discovery. Hoisting
gold or uranium, it still produced essential building blocks: carbon, oxygen, and nitrogen, all of which are crucial for life. And here's where things get truly remarkable. The sun's death will ensure that its elements do not go to waste. As the outer layers of the sun expand and drift into space during its red giant phase, they will enrich the interstellar medium, the vast empty space between stars, with the very materials needed to create new planets, asteroids, and perhaps even life itself. It is possible that millions or even billions of years in the future, those same elements will be gathered by a newborn star. They might become part of a planet forming in an alien solar system, and on that planet, deep within its atmosphere, some small trace of the sun's atoms could still exist. This means that even after our sun has long since disappeared, it might still be part of new worlds, new skies, and perhaps even new beings that will one day look up in wonder at their own sun, never knowing that part of their existence came from a long-dead star, light years away. The sun's part in the universe's fate. We have spoken of how the sun will influence the local solar system. But what about the larger cosmic picture? The universe itself is on a trajectory toward an uncertain fate. Some theories suggest it will continue expanding forever, cooling into a vast empty void where no new stars form, no galaxies shine, and no heat remains. Others predict a big crunch, where everything collapses back into a singularity, potentially leading to another Big Bang, a cycle that could repeat endlessly. But regardless of which destiny awaits the cosmos, the sun has played its part in shaping it. Through the energy it released, the planets it influenced, the materials it forged, and the systems it disrupted, the sun has left an irreversible fingerprint on the history of the universe. Even in the distant future, as galaxies drift apart and the last stars flicker out, the sun's light, though faded beyond recognition, will still be part of that story. It has ignited worlds. It has given birth to life. It has sent waves of energy through space that will continue traveling until the very end of time itself. And even when there is no one left to witness it, when the last remnants of civilization have faded into memory, the sun's existence will still be written into the very fabric of the cosmos. We often think of death as an ending, but in the grand scheme of the universe, nothing truly disappears. Everything transforms, everything is repurposed, and everything leaves behind an echo. Even in the silent, darkened remains of a once mighty star, the sun's influence will linger for eons, its presence felt in ways both visible and invisible, across time and space. But what happens when the sun is no longer recognizable? When it is no longer a bright burning star, but a mere ember of what it once was? How does its final whisper continue to shape the universe around it? The fading glow, a white dwarf's slow journey to darkness. Once the sun has exhausted all its nuclear fuel and cast off its outer layers, its core will collapse into a white dwarf, an Earth-sized but incredibly dense remnant of what was once a thriving star. At first, this white dwarf will still glow faintly, radiating away the residual heat trapped within. But unlike a living star, It will no longer generate new energy. No more nuclear fusion. No more solar flares. No more solar wind shaping distant worlds. The sun's light, once a blazing force that could be seen from the furthest reaches of the solar system, will now be a faint and dying ember. Yet, this process is incredibly slow. A white dwarf takes trillions of years to cool completely. For comparison, the current age of the universe is only about 13.8 billion years, a mere blink of an eye, compared to the lifespan of these stellar corpses. This means that long after humanity, long after Earth itself has been swallowed or frozen in time, the sun's white dwarf will remain a ghostly beacon in the sky, still radiating its final warmth across the abandoned solar system. A dark future, the black dwarf era. But what happens when the white dwarf cools to the point where it no longer emits any heat or light at all? This is where things get truly eerie. A white dwarf eventually becomes what scientists call a black dwarf, an object so cold, so ancient, that it barely interacts with the universe at all. But here's the mystery. No black dwarfs exist yet. Why? Because the universe is still too young for any white dwarf to have completely cooled into one. This is a process that takes quadrillions of years, thousands of times longer than the current age of the universe. This means that in the unimaginable future, when the cosmos itself has changed beyond recognition, the dead sun will persist as a frozen invisible relic, a reminder of a time when stars still burned, planets still orbited, and life still thrived under its warm glow. Imagine drifting through space in this distant future, through a universe where no new stars are being born, where galaxies have long since faded, and where the last remaining celestial bodies are nothing but cold, silent husks. The sun, once the giver of life, will now be a frozen monument to the past, buried in eternal darkness. The fate of the solar system. Will the planets survive? But what of the solar system? What of the planets that once danced in perfect harmony around the sun's gravitational pull? By the time the sun becomes a black dwarf, its grip on the solar system will have changed dramatically. As it lost mass over the eons, its gravitational pull weakened, allowing the outer planets to drift farther away. Some planets may remain loosely bound, orbiting the invisible husk of their former star in vast elongated paths. Others, however, may not be so lucky. Over the eons, gravitational disturbances, whether from passing rogue stars, galactic collisions, or even the pull of the Milky Way's center, could eventually rip the remaining planets from their orbits. Imagine Jupiter and Saturn, once steadfast giants of our system, slowly wandering away into the darkness, forever lost to the void. Earth, if it even still exists at this point, will be nothing but a frozen rock. If it was not consumed by the sun during its red giant phase, it will now be an unrecognizable husk, lifeless, and battered by the passage of time. Its continents will have eroded beyond recognition, its atmosphere long since stripped away. Nothing will remain of the cities, mountains, or oceans that once flourished under the sun's warmth. No
T-minus 5, 4, 3, 2, 1. Booster ignition and liftoff of Discovery, hoisting harmony to the heavens and opening new gateways for international science. Discovery has cleared the tower.
Houston now controlling.
Roll program.
Roger, roll, Discovery.
Discovery's roll maneuver is complete. Is now in a heads-down position on track for its flight to the International Space Station.
What is dead today might be the building block of something new tomorrow. One possibility is that far into the future, the remains of the sun could one day be pulled into the heart of the Milky Way, where it might eventually merge with other stellar remnants. If the sun's material falls into the galactic core, it could contribute to the growth of the supermassive black hole, lurking at the center of our galaxy. There its matter would be swallowed, its atoms stretched beyond recognition, its very existence consumed into an unfathomable singularity. Or perhaps if the Milky Way collides with another galaxy, something that is actually predicted to happen in the future, the remnants of the Sun could be scattered into a new region of space. Its atoms, once compressed in a cold dead star, might find themselves drifting through nebula, mixing with cosmic dust, waiting to be reborn. Could it be that trillions of years from now the very elements that once made up our Sun will help form a new star, one that will shine again over a brand new world? Could a new solar system emerge, built from the ashes of the old? Perhaps in some distant corner of the cosmos, a new sun will rise, a faint echo of the one that once bathed Earth in light, a faint echo of the one that once bathed Earth in light and warmth. And perhaps, on some alien world orbiting this new sun, a new civilization will one day gaze up at the sky, wondering about the past, asking the same questions we do today. Where did we come from? Where are we going? And what will happen when our star dies? A universe without stars, the final end. But even if the sun is reborn in some distant galaxy, there will come a time when the universe itself reaches its final age. The era of stars will not last forever. There will come a time when all the stars in the cosmos, every last one, will have burned through their fuel. No more light, no more warmth, no more warmth, no more energy to sustain new solar systems. A time will come when the last star in the universe flickers out, and all that remains are black dwarfs, neutron stars, and black holes, neutron stars and black holes. At this point, the sun, along with every other star that has ever existed, will truly be gone. It will be a universe of silence, a universe where not even a single beam of starlight will shine. And yet, even in that final darkness, the sun's atoms will still exist. And yet, even in that final darkness, the sun's atoms will still exist, scattered as dust across the vast and empty cosmos, silent reminders that once long ago there was light. As we move further into the sun's distant future, it becomes increasingly difficult to grasp just how vast these time scales becomes increasingly difficult to grasp just how vast these time scales are. We are talking about trillions upon trillions of years, lengths of time so immense that even the existence of time so immense that even the existence of the entire human race barely registers as a fraction of a second in comparison. And yet, even across these unfathomable ages, the sun's influence will linger, its dust sending ripples through the cosmos, in ways both expending ripples through the cosmos, in ways both expected and entirely unknowable.
But to truly understand what happens next, we need to step back, way back, and look at the universe itself. Because the sun's story is not just about one dying star. It is part of a much larger process, one that affects the fate of everything we know, the universe in motion. How the sun's death will reshape space itself. One of the strangest things about the cosmos is that it never stays still. At this very moment, galaxies are moving apart, stars are being born, and planets are forming from swirling clouds of dust. But as time marches forward, this motion will begin to change. Scientists have discovered that the universe is expanding, and it's doing so at an accelerating rate. This means that as we look further into the future, the distances between galaxies will only grow larger. So what does this mean for the sun's remnants? It means that as our white dwarf cools, the rest of the universe will be stretching apart, growing colder and darker as time moves forward. At some point in the far, far future, the sun's husk may no longer even be part of a recognizable galaxy. The Milky Way itself may be gone. The Milky Way's fate: will the galaxy survive? The sun is only one tiny part of the Milky Way, our vast spiral galaxy filled with hundreds of billions of stars. But the Milky Way itself is not eternal. In fact, scientists already know its fate. It will merge with our neighboring galaxy, Andromeda. Right now, Andromeda is racing toward us at about 110 kilometers per second, 68 miles per second. That might sound fast, but on a cosmic scale, it's actually a slow-motion collision that will take about 4.5 billion years to fully unfold. By the time this happens, the sun will already
T-minus 5, 4, 3, 2, 1.
Their shapes will
Booster ignition and liftoff of Discovery. Hoisting.
Some will be ejected into intergalactic space, and others may find themselves drifting dangerously close to black holes. But despite the chaos, individual stars, including the sun, are unlikely to collide. The vast distances between them make direct impacts incredibly rare. Still, the gravitational chaos will reshape the solar system's surroundings. By the time the merger is complete, the sun, if it still exists in some form, may no longer be part of the same familiar spiral structure we see today. Instead, it will be in a new reshaped galaxy, a giant elliptical galaxy formed from the union of the Milky Way and Andromeda. Would life exist anywhere in this future galaxy? Would new civilizations rise and look back at this ancient merger in the same way we look back at the formation of our own planet? If intelligent beings were to look at the sun's corpse, a faint white dwarf barely glowing in the sky, would they even know that it once powered a world filled with oceans, forests, and human civilizations? Or would they see it as just another dying ember, one of countless trillions scattered across the cosmos? The sun's lasting legacy. What it leaves behind. Though the sun itself will be dead, its existence will leave an imprint that lasts for an unimaginable length of time. For one, its light, despite having faded, will still be traveling through space. Right now, photons that left the sun billions of years ago are still racing through the universe, moving ever outward into the void. Somewhere, in some distant galaxy, those ancient rays of light might one day pass through an alien world, illuminating landscapes that no human will ever see. The sun's particles, its atoms and elements will also continue to exist. Every single element heavier than hydrogen and helium was created in stars like our sun. This means that the sun, though dead, will have played a direct role in shaping the chemistry of the cosmos. Perhaps, in some far-off place, a cloud of gas enriched by the sun's remains will help form a new solar system. A second chance, a cosmic rebirth. Could there be a world orbiting that new star? Could there be oceans? Could there be life? And if there is, would those distant beings ever wonder where their world's atoms once came from? Would they ever realize that long before their existence, those same particles were once part of a brilliant yellow star, warming a small blue planet called Earth? The slow march toward nothingness, a universe without stars. For now, the universe is still young. Stars are still burning, galaxies are still forming, and planets are still being born. But this will not last forever. The sun's death is only one small step in a much larger process, the slow, inevitable winding down of the cosmos itself. The era of stars will one day come to an end. At first, the massive stars, the ones far bigger than our sun, will die in dramatic explosions, forming black holes and neutron stars. Then over time, the smaller stars, the ones like the sun, will fade into white dwarfs before slowly cooling into darkness. As the universe reaches the end of its stellar era, the last stars will flicker out, and the cosmos will enter a time of eternal night. No more sunlight, no more galaxies glowing in the dark, just black dwarfs, neutron stars, and black holes all drifting in the cold emptiness. And yet, even then, the sun's remains, its atoms, its light, its energy, will still be somewhere, scattered across the endless void. The question is, will anything be left to see it? Will anything be left to remember the sun, and the world it once shined upon? Or will it all fade into silence, leaving behind nothing but a memory imprinted in the fabric of the cosmos itself? At this point in our journey through the sun's future, we find ourselves at a crossroads between existence and oblivion. The sun, now a white dwarf, has shed its outer layers, leaving behind a core that was once its beating heart. For a time it will still shine, though faintly, a ghost of the brilliant star it once was. But what does it mean for a star to truly die? Is it when it stops fusing elements? When it no longer produces heat? When it ceases to be visible at all? Perhaps in some ways the sun will never truly be gone. Its energy, every photon it ever released, will continue traveling through the cosmos, forever journeying outward, touching distant corners of the universe that no human has ever seen. But the question remains, how long can the sun's glow persist in the deep void of space? The slow cooldown. How long will the sun's core stay warm? The sun's transformation into a white dwarf is not an instant process. Even though it has stopped generating energy through nuclear fusion, it still retains an incredible amount of heat. Imagine an iron rod heated until it glows red hot. Even if you take it away from the fire, it does not immediately turn cold. It cools slowly, radiating its heat until it eventually reaches the same temperature as its surroundings. The same principle applies to the sun, except on a vastly larger and longer time scale. A freshly formed white dwarf can have a surface temperature of around 100,000 degrees Kelvin, several times hotter than the sun's surface today. But with no internal source of heat, this temperature will steadily decrease over time. At first, the cooling is rapid on a cosmic scale. At least, within a few 100 million years, the sun's remains will dim considerably, fading into the background of the galaxy. But then something strange happens. The rate of cooling slows down dramatically. White dwarfs do not cool linearly. Instead, as they become fainter, their ability to lose heat decreases. The sun's remnant will linger as a dull ember for trillions of years, its cooling process stretching far beyond the current age of the universe. So in a way, the sun's death is not just a single event. It is an incredibly slow, almost unnoticeable decline, one that will take place over a time span so enormous that it defies human comprehension. But
T-minus 5, 4, 3, 2, 1. Booster ignition and liftoff of Discovery, hoisting Harmony to the...
happens to white dwarfs over trillions of years. Right now, astronomers have never observed a fully cooled white dwarf. That's because the universe itself is only about 13.8 billion years old, far too young for any white dwarf to have completely faded. But based on our understanding of physics, we can predict what will happen. Over the course of trillions of years, the sun's core will continue to cool. Eventually, it will reach a point where its temperature is barely above absolute zero, the coldest possible temperature in the universe. At this stage, the sun's remains will no longer emit any visible light. It will have become a black dwarf, a frozen dark remnant drifting silently through space. But here's the twist. As far as we know, black dwarfs do not yet exist. Even the oldest white dwarfs in the universe are still glowing faintly. It will take hundreds of trillions of years before the first black dwarfs begin to form. This means that the sun's story is far from over. Even though it is no longer the brilliant star that once sustained life on Earth, it is still undergoing changes. Changes that will continue for a length of time greater than the entire history of the universe so far. The fate of the solar system. Will the planets still exist? But what about the planets that once orbited the sun? What will happen to them in this distant future? By the time the sun becomes a black dwarf, the planets of the solar system will likely be long gone. Here's why. The loss of the sun's outer layers will weaken its gravitational pull, causing the remaining planets to drift outward. Over billions of years, gravitational interactions with passing stars could destabilize the solar system, flinging planets into interstellar space. Some planets may even be pulled into the sun's dead core, spiraling in until they are consumed by its dense remnants. This means that eventually, the sun may no longer have any planets left. Instead, it will be a lonely black dwarf, floating in the void, with no remaining trace of the solar system it once ruled. But even this is not the final chapter.
because there is still one more cosmic force that will determine the sun's ultimate fate. The era of black holes, the final stage of the universe. By the time the sun has fully cooled, the universe itself will look drastically different. The expansion of space will have stretched galaxies apart to the point where they are no longer visible to one another. The era of stars will have long since ended, with no new ones being born. Instead, the cosmos will be dominated by the last remaining objects, black holes. These monstrous remnants of massive stars will be the final rulers of the universe. They will continue to exist even as everything else fades into darkness. But will black holes have any effect on the sun's remains? Possibly. Over vast periods of time, even black holes are not permanent. They slowly evaporate due to a process called Hawking radiation. However, this process is unimaginably slow. It would take far longer than the current age of the universe for even a small black hole to fully evaporate. This means that while the sun's black dwarf will drift quietly through space, there is always the possibility that, at some point, it could be consumed by a passing black hole. If this happens, the sun's remains will be pulled into the black hole's event horizon, where they will vanish from the observable universe forever. Would this be the true end of the sun? Or would its matter still exist in some form, hidden within the depths of the black hole, waiting for the moment when the universe itself ceases to exist? A star's legacy. What the sun leaves behind. Even though the sun will eventually fade from existence, its impact will never be truly erased. The atoms created in its core will continue to exist, scattered across the cosmos. Some of these atoms may become part of new stars, new planets, and even new forms of life. The light it emitted will continue traveling through space for billions of years. Somewhere in some distant galaxy, a photon of sunlight could still be racing through the void, illuminating unknown worlds. Even as the universe grows colder, darker, and simpler, the sun's influence will never fully disappear. It will be written into the very fabric of reality, a silent reminder of a once burning star that for a brief moment in time gave warmth to a small blue planet called Earth. At this point, the sun has faded into a dark, frozen remnant. The once magnificent star that lit up the solar system for billions of years is now a black dwarf, an object so cold and dim that is nearly invisible in the endless expanse of space. But even in this state, the sun's presence will not be entirely erased, because everything in the universe leaves an imprint, a trace, a mark on reality itself. The story of the sun's death is not just the end of one star, it is part of a much greater cosmic cycle, one that has been playing out for eons and will continue long after the sun is gone. So what exactly happens next? How does the sun's legacy ripple through the fabric of time? Let's explore the ways in which our dying star will still shape the universe, even in its darkest and quietest moments. The atoms of the sun, scattered across the galaxy. The sun was not always a massive glowing sphere of light. It began as a cloud of dust and gas, a swirling collection of hydrogen, helium and tritium, and trace amounts of heavier elements, formed in the hearts of previous generations of stars. Every atom in the sun has a history that stretches back billions of years, some even to the birth of the universe itself. And just as the sun was formed from the remnants of ancient stars, so too will its own matter continue its journey long after it has died. During the sun's red giant phase, it shed its outer layers into space. These layers were filled with elements that had been created through billions of years of fusion, nitrogen, oxygen, to life. As these elements drift into interstellar space, they will eventually mix with other clouds of gas and dust. Over millions of years, they may become part of new star-forming regions, or they will contribute to the birth of entirely new solar systems. In a way, the sun's death is not truly an ending. It is a transformation, a passing of the torch to the next generation of stars. The passing of the torch to the next generation of stars. Will the sun's atoms become part of new planets? It is entirely possible that, millions or even billions of years from now, the very same elements that once made of the sun these same elements that once made of the sun could become part of new planets in distant stars. Somewhere out there, a new world could form, a world with continents, oceans, and perhaps even life, containing traces of the sun's ancient matter. Perhaps on some distant planet in the far future, an intelligent species, the composition of their world, and targeted species or stations will study the composition of their world and find elements that once to the sun. Would they ever know the significance of what they discovered? Would they realize that these atoms once helped sustain life on a small blue planet called Earth? Or would the sun's legacy remain a silent mystery, woven into the structure of an alien world? The fate of the sun's light, a journey through time. Even as the sun itself fades into darkness, the light it emitted during its lifetime will continue its journey through the cosmos. Every photon of sunlight that left the sun is still traveling outward, moving at a speed of light, spreading across the universe. Some of these photons have already reached the edges of the Milky Way galaxy. Others will continue traveling for billions of passing through intergalactic space. Some may never encounter another ship, simply moving forever into the expanding void of the cosmos. Could some of the sun's light still be visible in distant galaxies? Could some of the sun's light still be visible in distant galaxies, eons from now? There may be civilizations in other galaxies that one day detect a faint ancient beam of light originating from
In a way, the sun's light is its final message to the universe, a signal from a time long past, a whisper from a star that once burned bright. The solar system's final days. Will anything remain? As we discussed in previous parts, the planets of the solar system will likely not remain in their current orbits forever. Over time, gravitational interactions will either fling them into deep space or send them crashing into the sun's remains. But what about smaller objects? The asteroids, comets, and icy bodies of the Kuiper Belt, will they still exist after the sun has faded? Surprisingly, some of them might. Objects that are far enough from the sun, like those in the Oort cloud, a vast distant region of icy bodies, could continue to orbit the dead sun for an incredibly long time. Some of these objects may remain untouched for trillions of years, drifting in the frozen outskirts of the solar system, long after the sun itself has disappeared from view. But even they are not truly safe from the slow march of time. Eventually, these distant bodies may be pulled away by the gravity of passing stars, lost to the galaxy. One by one, the last remnants of the solar system will be scattered, until at last nothing remains but the sun's dark, silent core, drifting alone in space. The sun's place in the grand timeline of the universe. At this stage, we have reached an almost unimaginable point in time, far beyond anything that human history has ever witnessed or ever will witness. By now, the universe has changed dramatically. Most stars have burned out, galaxies have grown dim. The cosmos is a colder, quieter place. The universe is now ruled by black holes, white dwarfs, and the long-dead remnants of stars like our sun. And yet, despite the changes, despite the vast eons that have passed, the sun still lingers as a shadow of its former self. Its story is not unique. Countless other stars have followed the same path. But for us, for those who once lived in its warmth, its death holds a special significance. It was the sun that gave life to the earth, that warmed its surface, that fueled the ecosystems and cycles that allowed our world to exist. And now it is gone. But even as the sun fades into the past, its story does not end, because it is part of a much larger cosmic tale, one that stretches beyond time itself. Part 16. The Final Echo. How the sun's death shapes the distant future of the universe. At this point in our journey, the sun is no longer the brilliant, life-giving star that once illuminated Earth. It has become something far quieter, a black dwarf, a frozen relic of its former self. But even in this state, its presence lingers in subtle ways. The sun's death is not just an isolated event, It is a small but significant part of the ever-changing, ever-evolving cosmos. In this part we will explore how the legacy of the Sun continues to ripple outward, affecting the distant future of the universe in ways both seen and unseen. The Black Dwarf Era, a universe of fading light. By the time the Sun has fully cooled into a black dwarf, the universe itself will have changed beyond recognition. The grand, vibrant galaxies we see today, filled with colorful nebulae and active stars, will have faded into near darkness. Most stars will have burned out. The youngest, slowest burning stars, red dwarfs, may still shine, but even they will be fading. Galaxies will be quieter, dimmer. The bright regions of star formation will be gone, and only the glowing cores of ancient black holes will remain. The universe will be colder, with fewer active stars. The temperature of space will continue to drop. The Sun's dark corpse, drifting in this vast and nearly empty universe, will not be alone. It will be one of countless black dwarfs scattered throughout the cosmos, silent markers of a universe that once burned with light. But even in this quiet, even in this deep and endless darkness, the story is not yet over. The fate of the Sun's dead core, will it ever be destroyed? Once the Sun has become a black dwarf, its fate seems sealed. It will simply exist, cold and lifeless, for the rest of time. But time is a strange thing. If we look far enough into the future, trillions upon trillions of years ahead, something unexpected may happen to the Sun's corpse. Some scientists believe that, given an unimaginably long time span, quantum physics may allow the Sun's atoms to slowly decay. This process, known as proton decay, is still purely theoretical. We have no evidence that it actually happens, but if it does, it could mean that over quadrillions of years the very atoms that make up the Sun could begin to break apart. If this is true, then eventually the Sun's remains will simply fade away into nothingness. Its atoms will disintegrate, dissolving into the fabric of space itself. And finally, after a lifespan spanning more than 100 billion times the age of the current universe, the Sun's story will truly come to an end. But there is another possibility. If protons do not decay, then the Sun's remains will continue to exist indefinitely, a frozen relic of a lost solar system, drifting forever in the dark. Which fate awaits the Sun? Will it dissolve into nothingness, or will it persist as an eternal monument to a vanished world? We do not yet know the answer, and we may never know, because we as humans will not be around to see it. Will the universe itself survive? Even after the Sun is gone, the universe itself will continue its journey. But what will happen to it? There are several possibilities for how the universe itself may end, each one more fascinating and mysterious than the last. 1. The Big Freeze. The most likely theory is that the universe will continue to expand forever. Over time, all the remaining stars will burn out, black holes will slowly evaporate, and the cosmos will become a vast, cold void, where nothing can ever happen again. 2. The Big Crunch. Some scientists believe that instead of expanding forever, the universe might eventually collapse back in on itself. If this happens, everything, including the Sun's remains, could be pulled together into a final cosmic implosion. 3. The Big Rip. Another possibility is that dark energy, the mysterious force causing the universe to expand, will eventually grow so strong that it will tear everything apart. Even atoms themselves would be ripped apart, leaving behind only energy. Each of these scenarios marks a different kind of ending, not just for the Sun, but for everything that has ever existed. The Sun's legacy. A universe forever changed. No matter how the universe ends, one thing is certain: the Sun's existence will have left a permanent mark on the cosmos. It was more than just a star. It was the source of all life on Earth. It was the reason our planet could support civilizations, cultures, and history. It was the silent guardian of a world that existed beneath its light. Even as the sun's corpse drifts in the dark, it carried with it the echoes of everything that ever happened under its warmth. Think about this. Every sunrise, every sunset, every moment you ever experienced in sunlight was part of the sun's journey. And even though the sun itself is gone, those moments still happened. They were real. They mattered. Looking back, a journey through time. As we stand at the edge of this long cosmic timeline, we find ourselves looking back at all that has transpired. The sun's birth, its brilliant golden years, the rise and fall of Earth beneath its glow, the slow inevitable march toward its death, the final embers of light fading into the infinite night. It is a cycle that has played out for countless stars before it, and will continue for countless more. But for us, for those who once lived beneath its warmth, the sun was special. It was our light, our guide, our silent witness to everything that has ever happened on Earth. And though it is now gone, its story will never truly fade, because it was a part of something greater. A universe that is vast, mysterious, and endlessly changing. A universe that, no matter how dark it becomes, once had a sun that shined. Part 17. Echoes of the Sun. The cosmic memory of a dying star. The sun has long since faded into darkness. Its once fiery heart has cooled, leaving behind a silent frozen remnant, a black dwarf, drifting alone in the vastness of space. But is that truly the end? Even after a star dies, its presence lingers in ways we can't always see. The sun may no longer shine, but its memory is imprinted into the very fabric of the universe. In this part, we will explore the ways in which the sun's death continues to shape the cosmos, long after its last ember has cooled. The sun's ghost, how it still influences space. Though the sun itself is no longer burning, its impact remains. The forces it set into motion still echo across space and time. 1. The solar system's orbits. Will they last forever? The sun was the gravitational anchor of the solar system for billions of years. Every planet, asteroid, and moon was held in its steady grip, orbiting in perfect balance. But now that the sun is a dark, lifeless object, what happens to the planets? Without the outward pressure of solar radiation, the balance of forces shifts. Over billions of years, the planet's orbits will begin to drift. Some may spiral outward, escaping into deep space. Others could be pulled into slow, endless collisions with what remains of the sun. Earth itself, if it still exists at this point, will be nothing more than a frozen, airless rock, tumbling in the darkness. The beautiful blue planet we once knew will be unrecognizable. 2. The asteroid belt and the fate of space debris. Without the sun's radiation pressure, small objects, like asteroids, comets, and dust, will behave differently. Some asteroids may fall into the sun's dark remains, disappearing forever. Others may drift aimlessly, lost, without the guiding force of solar wind. Some could even collide with the remaining planets, altering their fates in unexpected ways. Even without light, the sun's ghost continues to shape the space around it, whispering its influence on the universe long after its death. Minus cosmic relics. Where do the atoms of the sun go? Everything in the universe is made up of the same fundamental building blocks, atoms, forged in the hearts of stars. The sun spent billions of years converting hydrogen into helium, releasing vast amounts of energy in the process. But now that it's dead, what happens to those atoms? Scattered into the void over trillions of years, the sun's outer layers will continue to drift outward. Its atoms, once part of a brilliant fusion engine, will become tiny invisible fragments of dust scattered across the galaxy. Some will drift through space forever, never settling anywhere. Others may one day become part of something new,
perhaps even another star. 2. Reborn in a future generation of stars. In the far future, new stars will still be forming in other parts of the universe. These stars will gather material from long-dead celestial bodies, including black dwarfs like the Sun. It's possible that some of the atoms that once made up the Sun will be recycled into a new star, billions of years from now. That new star may even have its own planets, its own solar system, perhaps even life. In this way, the Sun's essence will live on, carried forward into the next era of the cosmos. Though the Sun is gone, it is never truly lost. Minus the memory of the Sun, can light ever truly disappear? Light travels at an astonishing speed, 300,000 kilometers per second. And once light is emitted, it keeps moving through space unless something blocks it. That means that even though the Sun has been dead for trillions of years, the light it emitted during its lifetime is still traveling through the universe. One sunlight, in the deep future.
Imagine standing on a distant planet, in a galaxy far, far away. If you had a powerful enough telescope, and if you were looking in the right direction, you might see a faint glimmer of light from a star that died long ago. That light could be from our Sun,
still traveling through the cosmos, long after it has vanished from our sky. In this way, the Sun's light continues on, spreading outward for eternity. 2. The cosmic background of stars. The cosmic background of stars that once were over time. The cosmic background of stars that once were over time. The cosmic backgrounds, the cosmic memory of all the dead stars in the universe. Even in a future where the Sun itself is gone, a trace of its warmth will still linger somewhere, in the vast and endless dark. This is the end, or just another beginning. Everything in the universe follows a cycle. Stars, is the end or just another beginning? Everything in the universe follows a cycle. Stars are born, they burn, and burn, and burn, and leave. But from their remnants, new worlds emerge. The Sun too was part of this cycle. It was not the first star, and it will not be the last. The atoms of the Sun will mix with the last. The atoms of the Sun will mix with the dust of the cosmos. Its gravity will shape the movements of objects long after it stops. Its light will travel endlessly through the universe. And so, in a way, the Sun never truly disappears. It simply becomes part of something greater.
Part 18. The Universe Without the Sun, a Journey into Infinite Darkness. The Sun has faded into obscurity. It no longer bathes the solar system in warmth, no longer rises in the sky, and no longer fuels the life that once flourished under its glow. But the universe does not stop moving. Time stretches on, trillions and quadrillions of years into the future. What happens in a cosmos where the Sun is nothing more than a dark, frozen memory? Does the universe itself begin to decay, or does it move toward a new era beyond anything we can imagine? In this part, we will take a deep journey into the unimaginable future, exploring what the universe looks like long after the Sun is gone. The fate of the solar system, a slow drift into oblivion. The Sun was once the anchor of the solar system, holding the planets in a careful gravitational dance. But without its energy and mass, that dance begins to unravel. 1. The planets' final journeys with no sunlight to guide them. The planets of our former solar system become cold, silent wanderers. Mercury and Venus, already swallowed by the Sun in its red giant phase, they are long gone. Earth, a frozen husk, drifting in the remains of the solar system. Its atmosphere is stripped away, its oceans long since boiled into space. Mars and the outer planets, their fates are uncertain. Some may remain in distant orbits, circling the Sun's black dwarf remnant. Others may slowly drift outward, escaping into the abyss. With no sunlight, everything is in permanent darkness. 2. The Kuiper Belt and Oort cloud, the last echoes of the solar system far beyond the planets. Countless icy bodies once existed. Comets, asteroids, and frozen worlds in the Kuiper Belt and the distant Oort cloud. These objects, once influenced by the Sun's gravity, are now free to drift. Some will be pulled into the Sun's remnant, Others may be ejected, flung into interstellar space, becoming eternal wanderers in the void. Eventually, the solar system as we know it will be unrecognizable. The familiar structure of planets, moons and asteroids dissolves into scattered fragments, fading into the cosmic background. Maina, the universe without our sun. A shifting landscape of stars. While the sun has perished, the universe itself continues evolving. 1. New stars are born. But not forever elsewhere in the galaxy. New stars are still forming. Clouds of gas collapse, igniting into fiery new suns, but this process is slowing down. Over time, the universe runs out of fuel. The vast reservoirs of hydrogen needed to create new stars are being used up. With each passing era, fewer stars are born. The night sky, once filled with the brilliant glow of distant suns, begins to darken. As time stretches forward, star formation ceases entirely. The universe enters a silent, fading twilight. 2. The death of other stars. A universe of stellar corpses. The sun is not the only star to face death. Across the cosmos, other stars are dying in their own ways. Smaller stars will burn through their fuel and turn into black dwarfs, much like our sun. Larger stars will explode in brilliant supernovae, leaving behind neutron stars or black holes. The most massive stars will collapse entirely, forming black holes that slowly consume the matter around them. Over the course of trillions of years, the universe becomes a cemetery of dead stars. No new light is being created. Only the silent remains of what once was. Black holes, the last rulers of the universe. As the last stars burn out, one force begins to dominate the universe. Black holes. 1. The growth of black holes. With no new stars forming, black holes, those strange inescapable voids, begin to take over. Some black holes slowly consume any remaining matter in their reach. Smaller black holes merge, forming supermassive giants. Entire galaxies begin to collapse into these gravitational monsters. In the distant future, the universe may be filled with nothing but black holes and frozen remnants of dead stars. 2. The slow death of black holes. Even they do not last forever. Even black holes do not live forever. Over unimaginable spans of time, they begin to evaporate through a process called Hawking radiation. It takes trillions upon trillions of years. But eventually, even the mightiest black holes will shrink. They will lose energy, becoming smaller and smaller. In their final moments, they will vanish into a burst of faint radiation, leaving behind absolutely nothing. The last black hole will fade away, marking the end of an era. There's his final fate, a cold, dark eternity. What happens when there are no more stars, no more black holes, no more energy? This is the question of the heat death of the universe. 1. The ultimate stillness. No more motion. With no energy left to fuel movement, the universe reaches a state of absolute stillness. Every atom, every molecule, every tiny particle has spread out to the point where nothing happens anymore. There are no more reactions, no more light, no more heat. The universe is at its lowest possible energy state, a frozen eternal void. 2. The last echoes of what once was, but even in this final dark chapter remnants of the past remain, the last scattered particles of dust, drifting endlessly, the final traces of radiation, so faint they are almost non-existent, the stretched out echoes of long-dead stars, still traveling through space, even if no one is there to see them. The universe has reached a state of perfect silence. Miners, the sun's legacy. Did it all matter? So after all this, after the sun has faded, the planets have drifted away, and the universe has reached its cold final state, what was the point of it all? The sun was just one star among countless billions. And yet, for billions of years, it gave life. It warmed a tiny planet, allowing life to rise, evolve and dream. It shaped the destiny of everything in its reach. It was part of a greater cosmic story, a story that, even in its ending, was beautiful. Though the sun's light has long faded, it was once there. And for those who lived beneath its glow, it was everything. Maybe that's enough. Part 19. Echoes of the Sun. Does anything remain? The sun's last embers have long since faded. Earth is a frozen relic, drifting alone. The planets have either been consumed or cast into the void. Black holes dominate the universe, slowly evaporating into nothing. And yet, even in this vast silent darkness, a question lingers. Does anything of our sun remain? In this part we explore the faintest echoes of the sun's existence, the hidden imprints it left on the cosmos. Even in the farthest reaches of time, could some remnants of our star still endure? Pause the solar system's shadow, lingering traces of a lost star. While the sun itself has ceased to shine, the story of its existence is not completely erased. Across the universe, subtle reminders of its presence remain, waiting to be discovered by any future beings, if such beings could ever exist. 1. Ghost particles. The sun's final whispers long after the sun has vanished. Tiny ghost particles, called neutrinos, continue traveling across the cosmos. Neutrinos are nearly massless, and can pass through almost anything without stopping. During its lifetime, the sun released trillions of neutrinos every second, and these particles are still out there, scattered through space. They do not interact with normal matter easily, meaning they could drift through the universe for eternity. Somewhere, in a distant galaxy, an advanced civilization might one day detect a faint stream of neutrinos, the last whispers of a long-dead star. 2. The cosmic microwave background. The sun's place in time. Though the sun itself is gone, the universe still carries the imprint of its past. The cosmic microwave background, CMB, is the oldest light in the universe, a faint radiation left over from the Big Bang. It serves as a time capsule, carrying information about every star that ever existed, including our sun. Even after the sun's disappearance, its influence on space-time, its gravity, its energy, its very presence, has left subtle distortions in the fabric of the cosmos. Billions of years from now, some future scientist, if any exist, may be able to reconstruct the sun's story from these barely perceptible clues. Minus a glimpse of Earth, could any trace of humanity survive? Our sun is not the only thing that has disappeared, so has everything it once illuminated. Earth, the home of all human history, is now a frozen, barren world. But could anything of us endure? 1. The Voyager probes, humanity's last message to the stars. In 1977, NASA launched Voyager 1 and Voyager 2, two small spacecraft designed to explore the outer planets. Today they are still drifting through space. Each carries a golden record, a message to any extraterrestrials who might one day find them. The record includes images, sounds, and music from Earth, as well as greetings in multiple languages. Over millions, and even billions of years, these probes will continue traveling through interstellar space. Even after the sun is gone, Voyager may still be out there, drifting between the stars, a silent reminder that we once existed. 2. The ruins of Earth, buried beneath ice and rock. If any advanced civilization were to visit our solar system trillions of years from now, what would they find? Earth itself would be a frozen rock, devoid of life. Most of what humanity built, cities, bridges, satellites, would have crumbled into dust long ago. But deep beneath the surface, some structures might remain, underground vaults, fossils, and artificial materials that nature cannot easily break down. Would any future explorers recognize what Earth once was, or would they see only an empty, frozen world, lost to time? Nisa, the end of the universe. The sun's legacy in an empty cosmos. As the universe drifts further into its final frozen state, the sun's influence grows even fainter. But what happens when there is nothing left? 1. The last sparks of light. The final glow of the cosmos. Even after all stars have burned out, a faint light may still linger in the darkness. Hawking radiation from evaporating black holes,
will release the last traces of energy into space. Extremely slow nuclear reactions might cause occasional flashes of dim light in some distant galaxies. But as time stretches forward, trillions, quadrillions, even googolplex years, all light will eventually fade. The last photons will drift endlessly, unable to reach any observer. The universe's true death, absolute stillness. After the final black hole vanishes, the universe enters its last phase. All energy is used up. There is no more heat, no more movement, no more change. The fabric of space itself stretches thin, with no structures, no matter, and no interactions left. The universe is a perfect void, where time itself becomes meaningless. And yet, even in this infinite silence, the sun once existed. It burned brightly for billions of years. It warmed a world that created life, intelligence, and civilization. It was part of something greater, even if everything eventually fades. Minus, did it all matter? A cosmic reflection. As we reach the end of our journey, one question remains. If everything eventually fades into darkness, did the sun's existence truly matter? Perhaps the answer is yes. The sun was just one of countless stars, yet it was the source of all life on Earth. It gave rise to everything we have ever known. Our world, our history, our memories. It allowed us to look up at the night sky and wonder, and perhaps that alone was enough. Part 20. A universe beyond time. Does anything truly end? The sun has long vanished. Earth is an icy ruin, drifting through an empty cosmos. The planets are either swallowed by the void or frozen in eternal silence. The Milky Way has merged with other galaxies and faded into darkness. The black holes, once the last great rulers of the universe, have finally evaporated, releasing their last whispers of energy. But now we ask the ultimate question: does anything truly end? This is the final chapter in our journey, where we go beyond the physical universe, beyond time, beyond existence itself, and explore the possibility that even after the sun's death, something may yet remain. The fate of the universe, the final silence. To understand whether anything remains, we must first consider what happens when time itself runs out. 1. The Big Freeze. The universe's ultimate death. If our current understanding of physics holds true, the universe is expanding, and it will never stop. Over trillions of years, the universe, the years, Sandman, the fire part, that their light can no longer reach one another. Stars stop forming. The last remaining ones burn out, leaving behind only cold, dead matter. Even atoms, the very building blocks of everything, begun to decay, breaking down into fundamental particles. The universe reaches a state known as heat death, a point where all energy is evenly spent, and nothing new can ever happen again. At this point, time itself loses meaning. There is no change, no movement, no interaction. There is no change, no movement.
No change, no movement, no interactions, only an endless silent emptiness. But is this truly the end? 2. The quantum possibility. Can something emerge from nothing, even in a universe that seems completely empty? The laws of quantum physics suggest that nothing may not be as empty as it seems. On an incredibly small scale, tiny fluctuations in energy are constantly appearing and disappearing. Particles can blink into existence for fractions of a second before vanishing again. This means that even after the last star fades, the universe may still have a kind of invisible activity beneath its frozen surface. Could these tiny fluctuations one day spark something new? Perhaps even a new universe? Minors. The endless cycle. Could the universe rebirth itself? If our universe had a beginning with the Big Bang, does that mean it could one day experience another? 1. The Big Bounce. A universe that never truly ends. Some scientists believe that instead of expanding forever, the universe might one day stop expanding and collapse back in on itself, leading to a new beginning. If this happens, all matter, all space, All time will shrink down into an infinitely small, infinitely dense point. Then, just as before, another Big Bang could occur, starting the cycle over again. This theory, known as the Big Bounce, suggests that the universe is eternal, constantly being reborn. If this is true, then perhaps our sun was not the first of its kind. Perhaps there were other suns before it, in other cycles of existence, ones we will never know. A universe beyond our understanding, the multiverse hypothesis. Even if this universe ends, could others exist? 1. The infinite realities, other universes beyond our own. The multiverse theory suggests that our universe is just one of countless others, each with different physical laws, different stars, and different possibilities. Some universes may have different types of physics, where stars never form at all. Others may be almost identical to ours, perhaps even containing suns just like ours, planets just like Earth, and even people like us. If true, then even after our sun and our universe are gone, the multiverse as a whole continues. In some distant reality, could there be another sun, another Earth, another version of us, looking up at their sky, and wondering the same things we are? The power of memory. Does the sun live on in another way? Even if everything physical fades, if the sun, the planets, the stars, and even space-time itself disappear, is there another way something could remain? 1. The imprint of existence. The universe remembers every moment of the sun's existence, left an imprint on the cosmos. The light that traveled from the sun for billions of years is still moving outward, carrying its energy across space. The planets that formed around it shaped the orbits and gravitational paths of objects for eternity. The life it helped create on Earth left behind traces in time, memories, thoughts, and ideas that shaped reality itself. In this way, the sun never fully disappears. 2. The human legacy. Our connection to the stars, more than anything. The sun's greatest legacy may have been us. It allowed life to form on Earth, to grow, to evolve, to wonder. It lit up our skies for billions of years, filling our world with warmth and energy. It gave rise to civilizations, knowledge, dreams, and stories, memories of the past that continue on in some form. Even when the physical world fades, we are the sun's memory. Even after it is gone, we were here, we saw it, we knew it, and for as long as there is thought, it will never be forgotten. Final thoughts. Is this the end, or a new beginning? As we finish our journey, we return to one last thought. Does anything truly end? Perhaps not. The sun's story is the story of existence itself, a tale of birth, life, death, and the possibility of something beyond. Even in the vast emptiness of the far future, the sun's light once shone, its warmth once filled a small planet where intelligent beings looked up, dreamed, and tried to understand the mysteries of the universe. Maybe that was the point. Maybe that was enough. And perhaps, somewhere out there, in another time, in another universe, another star is beginning its journey, just as our sun once did. Or is it?